Is QIDI's newly launched 3D printer, the Q2 Combo, that includes their new multi-material filament system called the QIDI Box, a worthy competitor to the top 3D printers such as Bamboo Lab P1S? That's what we're going to find out in this video. Hi, I'm Ken of Wrist Innovations, and welcome to today's video to take a peek under the hood of the newly launched QIDI Q2 Combo 3D printer. I'll cover initial prints, features, unboxing, cost, and the pros and cons of this printer, so you can make an informed decision on whether you want to consider buying this printer. I want to thank QIDI for sending me the Q2 Combo for my evaluation. Okay, so let's get started. I've only had the printer for a short time, so this will be an initial impressions video. I will follow up with a more comprehensive video after I have had time to test the printer over a longer period of time. Let's first start with the most important part of evaluating a 3D printer, and that's the quality of the parts. I printed parts using PLA, PETG, TPU, ABS, and carbon-filled nylon, and I think you're going to be surprised at the results. Since this is the first time for me to use the Q2 Combo, first I printed a preloaded design of a benchy in PLA, which turned out reasonably well. Then I began my more formal evaluation by printing a standard benchy designed by Creative Tools in PLA, which took approximately 51 minutes. The benchy turned out overall very nice. It had a more noticeable hull line than I'm used to seeing, but other than that, it looked good. Next, I printed this calibration test designed by Gabox 3D on printables using PLA. The overhang test successfully printed all the way to 80 degrees. The various cylinder diameters measured 10.02 millimeters, 7.94 millimeters, 5.86 millimeters, and 3.89 millimeters versus design diameters of 10 millimeters, 8 millimeters, 6 millimeters, and 4 millimeters respectively. The various rectangle lengths measured 10.17 millimeters, 20.07 millimeters, and 30.06 millimeters for design lengths of 10 millimeters, 20 millimeters, and 30 millimeters respectively. Bridging overall looked good, and there were little to no stringers on the Q2 part. Next, I printed this spiral vase design using PETG that was uploaded to printables by Max 413049. However, the original design is by Big Bad Bison on Thingiverse. The vase turned out well. It did have some random defects, but overall it was a nice part. If you need to print a part and you don't have a 3D printer, you can do that through the sponsor of today's video, PCBWay. You can go to PCBWay's website, upload your STL file, and they can make it and ship it right to your door. They have several 3D printing capabilities, including FDM, SLA, and SLS. They can also provide PCBs and PCB assemblies, CNC machining, sheet metal fabrication, and injection molding. I have personally used their services to 3D print a stainless steel insert for a high wear application. Their customer service and quality of parts are excellent. There is a link in the description below, and they will even provide you with a $5 welcome bonus. Thank you, PCBWay, for sponsoring today's video. This just in. I just learned last night that PCBWay will be having an 80% off sale during September for their 3D printing services for TPU-made 3D prints. This is a fantastic opportunity, so you don't want to miss this sale, especially if you have a TPU-related part that is too big to make on your own 3D printer. I will have more information about the sale during my September YouTube videos, so stay tuned. Now, back to our regularly scheduled program. Next, I printed this truck tire out of TPU, designed by Elbcom 193290 on printables. Since TPU can be stringy, I dried the spool of TPU in my Sunlu filament dryer at 55 degrees C for 6 hours. The QIDI box does have a filament drying feature. However, at least for TPU, the default setting is 65 degrees C for 18 hours, which I think is excessive, so that's why I dried my TPU in the Sunlu filament dryer. The TPU truck tire turned out great. There was very little stringing on the part. Okay, so now let's step up our game with a more challenging material, ABS. ABS can be a challenge because it tends to easily warp when printing because it really needs a warm environment. Another nice feature of the Q2 is it has an actively heated chamber heater, so the default setting for ABS is 65 degrees C. I haven't typically needed to dry my ABS before printing, so I decided to run a print before drying, and if it turned out poorly, then I would dry the ABS in the QIDI box and print it again. I printed this vice grips tool design by 3dprintedhardware.com. I did use the brim and support because there's a lot of overhangs and some of the parts did not have much contact with the build plate. I was really happy with the results from the Q2 because the vice grips turned out beautiful. None of the parts had any warping and the completed tool worked really well. Even though I'm not a big fan of multicolor printing due to the amount of wasted filament and how slow the prints take, I thought it was important to test the multi-filament capabilities of the QIDI box. So I had to print a multicolor print. I printed this articulated Rexagon Trex Plus Dragon Flexi by Pinky Wings on MakerWorld in 3 colors of PLA. The Q2 took 9 hours to print and it created a lot of filament waste, as most single nozzle multicolor prints do. For this print, the print itself used approximately 21 grams of filament, but it generated 132 grams of waste, or 6 times the amount of waste versus the actual part. I did have some issues where the print stopped approximately 6 times during the print due to the filament not being retracted in the QIDI box. To correct the issue, I hit the retry button and the print resumed. So I really don't know what caused this, but this was frustrating because I had to keep monitoring the print to keep it going. The print turned out reasonably well and all the joints easily moved. However, there were some strange layers that seemed to print in the wrong color, which caused these stripes on the part. Also, some of the layers towards the top of the print did not turn out well. Overall, I would give this part a grade of a C due to the things I just mentioned. Future Ken here. Last night I installed the second firmware update within approximately the last week, so I thought I had nothing to lose to see if this latest firmware update would possibly fix the issues I had with the QIDI box. I printed the same articulated Rexagon Trex Plus Dragon Flexi by Pinky Wings on MakerWorld, but this time I printed it in only 2 colors so that it would only take 6 hours, so that if the firmware fixed the problem, I would have the finished print in time for this morning's video launch. I went to bed wondering what I would find this morning. And what do you know? But the printer was working all night and it produced a beautiful part. The part didn't have any of the stripe issues or the poor filament layer issues I had with the previous print. I am very happy about this. So now let's get wild and crazy and print a part using glass-filled ABS. I placed a spool of glass-filled ABS in the QIDI box and set the drying temperature to 65 degrees C for 8 hours. Per QIDI's default setting. Note, the QIDI box's maximum drying temperature is 65 degrees C. A feature of the drying cycle is that the QIDI box rotates the spool every 5 minutes for more even heating. Also, there's a manual vent on the back to open up and let out the moist air, but you need to remember to close it after the drying cycle is completed. I decided to print these channel lock pliers designed by 3dprintedhardware.com. I did use a brim and support because there is a lot of overhangs and some of the parts did not have much contact with the build plate. I was really happy with the results from the Q2 because the pliers turned out great. None of the parts had any warping and the completed tool worked really nicely. Now, do you want to get totally nuts? How about printing a nylon carbon-filled part? Nylon is very susceptible to warping and is very sensitive to absorbing moisture, so it's recommended to dry PA12CF at 90 degrees C. For that reason, I placed a spool in my Sunlu dryer for 2 hours because the QIDI box can only reach 65 degrees C. Then I printed this pipe wrench designed by 3dprintedhardware.com. The pipe wrench turned out excellent. There was absolutely no warping and the pipe wrench works well. New Ken again. So, to summarize the parts quality section of this video, based on my experience with the Q2, it produces high quality printed parts that rival the quality of prints I get from my top printers such as the Bamboo Lab series of printers. It seems the latest firmware version that I installed last night fixed the issues I was having with the multicolor prints. Now let's cover the main features of the QIDI Q2 Combo. The QIDI Q2 has an overall printer dimensions of 402 millimeters wide by 438 millimeters deep by 494 millimeters high, and the QIDI box has overall dimensions of 357 millimeters wide by 300 millimeters deep by 234 millimeters high. Normally I would expect to be able to place the QIDI box on top of the printer, but QIDI recommends that when you are printing PLA, to place the QIDI box next to the printer and open up the top at least halfway. The adjustable top is nice, but I'm not a big fan to have the QIDI box sit next to the Q2 and take up so much precious space on the shelf or my workbench. The Q2 weighs 18 kilograms and the QIDI box weighs 4 kilograms for a combined weight of approximately 22 kilograms. The Q2 print volume is 270 millimeters by 270 millimeters by 256 millimeters. The Q2 is a fully enclosed Core XY printer made from a rigid internal metal frame and a glass top and door. It has X-axis linear guide rails and a 1.5 gear tooth belt, which QIDI claims offers smoother motion. The Q2 has a maximum hot end temperature of 370 degrees C and a maximum build plate temperature of 120 degrees C. The Q2 has a maximum speed of 600 millimeters per second and a maximum acceleration of 20,000 millimeters per second square. It has a filament runout sensor, chamber fan with a carbon and HEPA filter. The Q2 has a nozzle wipe feature. It also has a new nozzle sensor that is unaffected by the bed surface material. And in fact, QIDI has a video showing how they printed on fabric, marble, glass, and even wood, which is pretty amazing. It has an actively heated chamber that can reach 60 degrees C, and the Q2 has a multicolor filament multi-material capability when using their new QIDI box. The QIDI box can recognize the RFID tags in the QIDI filament spools that allow the QIDI box to recognize the color and specific material of each spool. Each QIDI box unit can hold 4 spools of filament, and you can connect as many as 4 QIDI boxes to the printer for a maximum of 16 colors. The QIDI box is one of the few multi-material modules on the market that have filament drying capability, which can dry filaments to 65 degrees C. Just as with other multi-material modules, the QIDI box cannot be used with TPU, PAHT, CF, and other very rigid or very flexible materials. To remove a spool of filament from the QIDI box, go to the filament menu, click on the spool you want to remove, then click the Remove button. The stepper motor rewinds the filament back onto the spool until it is completely out of the feed mechanism. Don't ask me how I was struggling to remove filaments before I noticed the Remove button. The Q2 comes with an auxiliary parts cooling fan and a textured PEI build plate. The Q2 works with the QIDI Studio Slicer, and they are developing a new phone app that should be launched shortly. The Q2 can print wirelessly using the QIDI Studio Slicer, and it can print in LAN mode. The Q2 has auto bed leveling, Z-axis offset, power loss recovery, and an internal LED light. You can print the following filaments on the Q2: PLA, PETG, TPU, ABS, ASA, PA, PC, and carbon-filled or glass-filled materials. The Q2 has a 4.3-inch colored touchscreen to interface with the printer. The Q2 has a 1080p resolution camera that offers AI detection. You can transfer files using a USB drive. QIDI has stated in the literature they provided me that the Q2 is the first 3D printer to obtain the US MET Product Safety Certification. What does MET certified mean, and who performed the testing? The MET certification means a product has been certified by MET Labs to meet applicable safety standards in the US and Canada. MET Labs is a nationally recognized testing laboratory. Now, let's unbox and set up the Q2. For my Q2 combo delivery, the printer and the QIDI box came in 2 packages because I asked for the version of the QIDI box that could be retrofitted to the Plus 4 printer. Based on what I can tell, production orders of the Q2 combo will have the QIDI box shipped inside the printer, just like several suppliers ship their multicolor filament modules. Once you remove the Q2 from the box, it's just a matter of removing the various foam packaging from the printer and opening the 2 accessory boxes. The accessory boxes contain the toolkit, Ethernet cable, power cord, scraper, filament holder, and screwdriver. The top of the box contains the glass top, filament holder arm, and the touchscreen. First, attach the touchscreen to the ribbon cable in the front of the printer and snap the touchscreen in place. Next, loosen 4 screws that are holding the build plate to the printer. Then, cut the cable ties from the X-rail and remove the cardboard from the tool head. Insert the PTFE tubing into the tool head. Install the glass top. Unpack the QIDI box. The QIDI box will contain cables to connect to the Q2, a power cord, a box filament hub, and new tool head if you are mounting the QIDI box to a +4 printer. Attach the box hub to the back of the Q2. Connect the 4 PTFE tubes to the box hub and to the QIDI box. Connect the PTFE tube from the Q2 to the outfeed of the box hub. Plug the 8-pin end of the signal cable into the Q2 and the 4-pin end into the QIDI box. Plug the 8-pin end of the box hub cable into the QIDI box and the other end into the box hub. Attach the power cords to the Q2 and the QIDI box. Plug them into an electrical outlet and turn the printer and QIDI box on. Follow the screen prompts by choosing a language and follow the instruction, including removing the foam from underneath the build plate. The printer will perform a self-inspection and then input shaping and auto bed leveling. Load some filament into the QIDI box unit. I also uploaded QIDI's latest slicer software onto my computer. Finally, I was ready to print my first part. Now let's talk about the cost of the Q2 Combo. At the making of this video, August of 2025, the QIDI Q2 without the QIDI box is currently on sale for $449. The QIDI Q2 Combo with the QIDI box is on sale for $599. The QIDI box by itself is on sale for $228. As a comparison, the Bamboo Lab P1S without the AMS is on sale for $549 and $749 with the AMS, and $869 with the AMS2 Pro. So, the Q2 Combo is $270 less than the P1S Combo with the AMS2 Pro. Now, let's go to my pros, cons, and final summary to see if spending $270 less for the QIDI Q2 Combo is worth it versus buying a Bamboo P1S Combo. Let's start with the pros. Overall, I'm impressed with the quality of the prints I made on the QIDI Q2, including prints made from ABS and carbon-filled nylon. For a variety of parts, I consider the print quality to be comparable to the quality from the Bamboo Lab P1S. It seems the latest firmware that I implemented last night has corrected the issues I was having with printing my multicolor prints, so time will tell as I test the Q2 further. But I am quite pleased with the quality of the parts I've made so far from the Q2. The Q2 has a print volume of 270 mm by 270 mm by 256 mm. The Q2 is a fully enclosed Core XY printer made from a rigid internal metal frame and a glass top and door. It has X-axis linear guide rails and a 1.5 gear tooth belt, which QIDI claims offers smoother motion. The Q2 has a maximum hot-end temperature of 370 degrees C and a maximum build plate of 120 degrees C. The Q2 has a maximum speed of 600 millimeters per second and a maximum acceleration of 20,000 millimeters per second squared. It has a filament runout sensor, chamber fan with a carbon and HEPA filter. The Q2 has a new nozzle sensor that is unaffected by the bed surface material, and in fact, QIDI has a video showing how they printed on fabric, marble, glass, and even wood, which is pretty impressive. It has an actively heated chamber that can reach 60 degrees C. The Q2 has a multicolor filament multi-material capability when you're using their new QIDI box, and you can link them together for up to 16 colors. The QIDI box is one of the few multi-material modules on the market that have filament drying capabilities, which can dry filaments up to 65 degrees C. The Q2 can print wirelessly using the QIDI Studio Slicer, and it can print in LAN mode. The Q2 has auto bed leveling, Z-axis offset, power loss recovery, and an internal LED light. You can print the following filaments on the Q2: PLA, PETG, TPU, ABS, ASA, PA, PC, and carbon-filled or glass-filled material. The Q2 has a 4.3-inch color touchscreen to interface with the printer. The Q2 has a 1080p resolution camera that offers AI detection. QIDI has stated in the literature they provided me that the Q2 is the first 3D printer to obtain the US MET product safety certification. Now the cons. For printing PLA and TPU, QIDI recommends moving the QIDI box from the top of the printer to next to the printer and opening up the lid to prevent too much heat from building up and causing nozzle clogs. This is a big negative for me because most people have their printers on shelves, so shelving space is a premium. Also, if you thought it was tough to remove a broken piece of filament from the Bambu Lab AMS unit, performing the same task on the QIDI box is significantly more work. I didn't spend a lot of time on this, but it wasn't clear to me on how to even take the QIDI box apart to remove any broken filaments. I'm sure QIDI will be providing some instructions in the near future, but I predict this will be quite involved. Future Ken here. I have since come across a YouTube video from Harry Ma 3D, who is a QIDI distributor in Malaysia. And he shows what is involved with taking apart the QIDI box, so I've included their link in my description. As I suspected, it is quite involved to take apart the QIDI box if you have a broken filament in the tubing. My overall first impression is that the QIDI Q2 is a worthy competitor to the Bambu Lab P1S. I think for somebody on a budget, buying the Q2 at $449 is a good value versus the $549 for the Bambu Lab P1S. If you want to pick up one of these puppies, I have an affiliate link in the description if you are interested, and it would also help me and my channel. What do you think? Which of these two printers would you buy? Let me know in the comments below. If you'd like to see my video titled Elegoo Centauri Carbon Printer, better value than Bambu Lab P1S, that link is here. If you'd like to see my video titled Anycubic Cobra S1 Printer, better value than Bambu Lab P1S, that link is here. Thanks for watching. Bye!